This is Coordinator here, and I am about to show you L'Hopital's rule. This is another method for solving limits in addition to the ones discussed in class. So let's see what we have here. Right here we are given the square root, the limit as x approaches 5 for the square root of x squared minus 81, all that plus 9, over 3x squared. So, how do we do that? Well, the first step is to take the derivative of both sides. But remember, every step of the way you gotta bring the limit down. So, the limit as x approaches 5 equals the derivative of the following. In the numerator, well, since the derivative rule for a square root function is 1 over 2 root x, you have 1 over 2 times the square root of x squared minus 81, but there's a chain rule in there. Since you took the derivative of the thing inside the square root, you got to multiply by the derivative of that thing, which is 2x. And the denominator is 6x. That's the derivative of the denominator. First step done. The next step is to, again, bring the limit down. I don't know why this keeps giving me pop-up ads as well. So limit as x approaches 5 is equal to, well, since we have a fraction over a denominator, we can multiply by the reciprocal, which is 2x times 2x over 2 root x squared minus 81 and that all multiplied by 6x. Take the reciprocal of that. Next step, bring the limit down. Gotta keep bringing the limit down every step of the way. Your teacher will expect you to do that. That means the limit as x approaches 5 is equal to 12x squared, because every time you multiply x's you get x squared, over 2 times the square root of x squared minus 81. But 12 divided by 2 is 6, so you can simplify that to just 6 over 1. So therefore you have 6x squared over the square root of x squared minus 81. Now, what do we do next? We plug in 5. When we plug in 5, we get in the numerator 6 times 25, which is 150, over the square root of 25 minus 81. I know what you're thinking. The limit does not exist here. Well, yes, that is correct. But here's why the limit does not exist. The reason why the limit does not exist is because the limit as x approaches 5 results in 150 over the square root of a negative. And that is not okay. 25 minus 81 will be negative. Yep, that's negative square root. That's negative 56. And you cannot have a negative inside the square root. So that means the limit as x approaches 5 does not exist. How about another one? Let's do one called I'm sorry if this is taking so long. I'm looking in my notes. How about the limit as x approaches negative 7 for an equation like two over x minus seven over 8, all that over the equation. Let me think. X plus 4. Once again, the first step, take the derivative of both equations. Now, the derivative of a number over x is 1 over that number x squared. Is that number over x, well, negative that number over x squared. So, and the derivative of negative 7 over 8 is 0. So the derivative here is negative 2 over x squared. Let me check. Derivative. Let me see. I'm sorry if this is taking longer than it should. The derivative, I'm looking for the derivative of 2 over x. I'm pretty sure it's negative 2 over x squared for confirmation. Yes, it is negative 2 over x squared. And the derivative of x plus 4 is 1. The next step, multiply by the reciprocal, which just gives me, and keep bringing the limit down because you're going to get in trouble. That's negative 2 over x squared. Now, now you plug in 7 to find Plug in negative 7 to find the limit. That's negative 2 over 49. So the limit as x approaches negative 7 is negative 2 over 49. And we're good. Now, how do we know the limit does not exist? We either have a negative square root or a 0 in the denominator.